Knovenogel reaction. Again the same thing only. For Perkin we said I need aromatic aldehyde. For this reaction also I need aromatic aldehyde. The only difference here that in Perkin I used anhydride. Here I am going to use an ester here. The very common ester that we use here is malonic ester. In the presence of the base pyridine, just by looking at it, I can understand malonic ester definitely will be having this unit here, COOR, where this is electrophilic in nature. So definitely that carbon which is present here would be acidic, would have given you negative charge. That would have attacked this carbonyl and the same further reaction would have happened. Same product value you got in Perkin as well as in this reaction, isn't it? So I'm having CH2COO C2H5 twice here. So similarly, I created a carbanion. The carbanion attacked the carbonyl and the reaction got completed with the formation of this hydroxyl group. Okay. Now we are providing an H2O in the presence of H plus. So it's an ester hydrolysis reaction. We know very well when an ester is getting hydrolyzed, you will get carboxylic acid and alcohol. So 2 moles are present here. So we form 2 moles of carboxylic acid. This is gem dioic acid. Geminal dioic acid. On the same carbon, 2 carboxylic acids are there. So whenever you are having gem dioic acid, you can remove carbon dioxide from there. I am removing carbon dioxide here so that it forms carboxylic acid. Now the next step, you heat it. Carbon dioxide is removed. Carbon dioxide is removed in the previous step itself. Again, you heat it, where you will form alpha beta unsaturated acid. This is again cinnamic acid. The next reaction is called Riffermotsky reaction, where from the carbonyl, you can produce beta hydroxy ester. I take a carbonyl, I want to convert it into beta hydroxy ester. You can use Riffermotsky reaction here. To this we use alpha halogenated ester, zinc upon heating, followed by hydrolysis. So it's not a thing that, ma'am, if I will know the mechanism, then I can prosecute it. Even this common reactant and the common product, if you know it, there are many JEE advanced questions, and they go for the master foreign type. They just give you carbonyl in one column, second column is an alpha halogenated ester, third column is a beta hydroxy ester. So we need to know the common names of the reactant and product as well. Okay, so I'm having a carbonyl here. I'm having an ester. I'm having halogen that is attached to that is alpha halogenated ester. The moment I see it, I could see that I'm using zinc here, bromine is here. It is very similar to your Grignard reaction where you go for an insertion, isn't it? I have CH3Br, I treated magnesium, you say it forms CH3MgBr. Same logic happens here. You can see it is getting inserted here. The next reaction is very similar to what you have studied with respect to your Grignard. What do you do in Grignard immediately? The next step, I'm having carbonyl, C double bond O is there. This is negative. So what will the negative do? The negative will go and attack over there. So the double bond O is getting shifted. That Z and Br would go and attached, isn't it?
Yes, ma'am.
Same logic happens here. The next step you should know definitely.
Ma'am, isn't this just like Grignard? Oh yeah, yes, ma'am. Yeah, you told sir.
That's what I'm saying.
Yes,
Very
ma'am.
similar to Grignard mechanism. So you hydrolyze it, so it becomes OH and CH to CORL. So what you see is alpha, this is beta, beta hydroxy ester you have formed. Okay, so we learned about the Reformatsky reaction where you convert a carbonyl compound into beta hydroxy ester. 12 இல்ல 1 o'clock முடியும். நீங்க போய் ராஜ்குமார் ரூம்ல ஓபன் பண்ணுங்க. எதுக்கு?